so we're going to take a look at solving systems of equations, and what a system of equation is two or more equations that contain the same variables. And that doesn't necessarily mean letters. In a word problem, the same variable could be the number of bars of cookies purchased. And if that's in two equations, that's a system. So this is a system of equations, and they want us to solve it graphically. To do that, well, first they didn't even give us a grid. Well, they gave us a grid, but they didn't even give us axes. So let's just make some axes just for the sake of having some sort of starting point here. This came off a Regents exam. Alright, so this one is already set to graph, and just so we can tell them apart, I will do it in blue. Plot a point at -1. The slope is -2/1, because it doesn't list it. So that says go down 2/1, so this is our next point, and just for the sake of making it a bit more accurate, I will plot several. Now we can take a straight edge and draw a line going upwards through all the points, and that seems about accurate. Let's put some arrows on here for accuracy, and we should always label it to make sure we get full credit. Okay, now the other one. That one's not in slope-intercept form. You could solve it for y, which I will do over here. I'll do that in red. This is the red line. Okay, so in red we have 4x minus 2y is equal to 10. We can subtract 4x from both sides. That'll give us -2y is equal to -4x plus 10. Divide both sides by -2. We'll get y is equal to 2x minus 5. Okay, so plotting this now, we can go down to -5. That's 3, 4, 5. Our slope is 2/1. Just to make sure that doesn't confuse anyone, do that in another color. There's no denominator listed, it is a 1. So we're going to go up 2/1, which you can see immediately connects at this point. Alright, I won't make as many points here, just to get this over with, because we do have more problems to get to. So, putting arrows here, this is, I like to write the original equation, because that's what my grader will be curious if I knew which one was which. So, what is the solution to a system of equations? Well, the solution to a equation is any point that satisfies it. So the solutions to the blue equation are all the points on this line. The solution to the red ones are all the points on this line. So there's only one solution to both of them, and that's located here at this intersection point, and that appears to be the point 1, -3. And we can test that by substituting it into both equations and checking that it works. That is not how I'm going to spend the time of this video for you, but you could always check it yourself to make sure. Is there anything we could change here? One thing that I'd like to mention is that the original equation here is actually written in what's called standard form. We put it in slope-intercept form for easy graphing, but if you look at standard form, we call it, we use capital A, capital B, and capital C. You would solve that the same way we solve this one. Subtract ax from both sides. I'll even use the same colors for it, just to make sure it's very clear. So that is by is equal to -ax plus c. Divide both sides by b. And that gives us y is equal to -a/b x plus c over b. So, if you have an equation in standard form, the slope will always be equal to -a/b. So just looking at this, we can see that the slope is going to be -4 over -2, which is just 2. which is what that is. The y-intercept will also always be c divided by b. So looking at this, I could say 10 divided by minus 2 is negative 5. So that's a really short way to find the slope and y-intercept without actually writing in slope-intercept form. So the b is always equal to c over b. So that's just a shortcut way of doing it, and sometimes it'll be faster. Alright, so that might be good to take down into your notes. Alright, so we're going to look at a system of inequalities. Again, they're both actually not solved for y. And just to show you that this works, I could tell you that the slope of the first line is negative a, so that's negative 1 over, that's negative 1 over 1, and the y-intercept is 3 divided by 1, so 3 over 1, or just 3. Let's just write it as 3, I don't want to confuse anyone. So that's 3, and I'll do it over here just so that there's no confusion. Subtract x from both sides. And we get y is greater than or equal to negative x plus 3. So the slope is negative 1 over 1, and the y-intercept is 3. So rather than take the time to solve it, you can just do it that way. So this first inequality will be graphed by plotting a point at 3, going down 1 over 1, say here. Just to make it a little bit more straight, I'll use a couple extra points. And because this is greater than or equal to, we get a nice solid line. With inequalities, I tend to make sure I use the entire graph. You might have noticed in the other one I didn't go all the way with the line, and that's because I need to shade a reasonable area here. So because this is y is greater than, I can shade above the line. So pick any point on the line and move up. That tells us which side's above. So that's this side. We draw perpendicular lines for our shading. Alright, so this is this area is y plus x is greater than or equal to 3. Now the other one, very quickly, I do that one in blue. Just looking at the coefficients, I could say this is negative 5 over negative 2, or the slope is 5 over 2, and the intercept is, should we make that lowercase b, lowercase b. It's going to be 10 divided by negative 2, or negative 5. Just to make sure that's clear, that's me using the standard form formulas I gave on the previous slide. We have y, 5x minus 2y is greater than 10. Now I actually do need to solve this one using slope-intercept form because it's an inequality, and it looks like that golden rule we've mentioned before is going to come up. Because the golden rule is going to come up, I'm not sure which side the inequality will face in the end. So that's negative 2y is greater than negative 5x plus 10. Divide both sides by negative 2, and that will become y. Since we divided by a negative, this has to reverse. This is negative divided by negative is positive, so that's just 5 over 2, as was stated over here. And 10 divided by negative 2 is negative 5, also as stated over here. So either way works. Use what's comfortable for you. So we'll start at negative 5, so that's 1, 2, 3, 4, 5, which is all the way down here at the bottom of my recorder. Alright, and the slope says to go up 5, 1, 2, 3, 4, 5, and over 2, which is here. Alright. And I want to keep everything on screen, so I might not shade below the screen here, but normally I would. I'm making a mistake here because this line is supposed to be a dashed line, because it is not equal to. See, not equal. gets a dashed line. Alright, now, shading. This says y is less than, so we shade below. Pick any point and go down, which is this side. So by shading, we wind up over here. So this inequality, this shaded region is y is less than. Probably better to use the actual equation they used. This is 5x minus 2y is greater than 10. Alright, so if we look at this question a little more clearly, we're looking they want the coordinates of a point that satisfies this one, but not the other one. So that would be any point in this region. So this satisfies the red one, but not the blue one. So to answer their question, I would pick this random point, or that one, whatever. This is 8, 0, 8 would be one that satisfies this, but not that. Alright, so make sure you read the questions carefully. Now for the hard one. Okay, so this is a system of a quadratic and a linear. They both need to be solved for y, so just move this along quickly. Subtract 2x from both sides. You might need to write the quadratic in standard form as well. That will give us y is equal to negative 2x plus 5. So plotting a point at 5, that's 1, 2, 3, 4, 5. It's here. Follow the slope, which is down 2, and over 1. And that's a positive over. So we can go down 2 over 1, which is here. Keep doing that. Graph a line. Okay. And now the parabola, which we'll do in blue. Actually, we'll do the parabola in green. So this in green. For this we make a table. X, Y. We need to know what the axis of symmetry is. So x is equal to minus b over 2a. So we have x is equal to minus negative 6 over 2 times 1. And that's because a is 1. B, sorry if there's some sort of confusion at this point, because I had to cut the video back because I made a mistake somewhere. That was kind of a waste of time. So yeah, so we're looking for the axis of symmetry. We plug in the values, and we get x is equal to 3. That's why it'll be the middle value of my table of values. To find out what the vertex is, we plug in 3. So that's 3 squared minus 6 times 3 plus 5. So that is 9 minus 18, which is negative 9, plus 5, which is negative 4, which is where I made my mistake earlier. I put a positive 4, which is what made me redo the video. Check a few values above and below the vertex. So that should be negative 3 and 0, and that should be negative 3 and 0. I'm not going to take the time to plug it in now. We don't have time for that. So 3, negative 4 would be our vertex. And we have some other points here. 1, 0, and here. And if we actually continue this one more point, I think we pass through here as well. So we also have 0, 5, and 6, 5. This is probably the only time I've ever seen it come up where I actually had to go an extra value like that. So now graphing this. Alright, so the solutions here are whatever that point is. What is that? That's 4, negative 3. And over here, which is 0, 5. Okay. Now, let's say these were inequalities. I have like 20 seconds, so I gotta hurry up. If these were inequalities, let's say they were both greater than, so greater than and greater than, we would shade in here, because this is above the parabola, and here would be above the line. So a point in the solution set would be one like this.